So, let me get started. I think we have 15 minutes. I'll introduce myself towards the end of the talk. Um, not to demean my credentials right at the beginning. This talk is bound to cause a little bit of controversy. It's mainly because I'm going to be advocating a little bit of doing things the good old way, rather than getting, like caught in the frenzy of front-end development. So I'm going to talk to you about how we rebuilt over 5 years 3 times the same application, and you're already been thinking that these guys must suck a little bit. So we run an e-commerce platform in the Middle East. We're based off of Dubai. Our company is Namshi. So we sell fashion items. Yo, too cool for school. So we run an e-commerce platform, the largest fashion retailer, e-retailer in the Middle East. So we sell products, shoes, and so on. I mean, I'm not part of the ads, of course. Through like various mediums, like mobile apps, mobile website, a desktop website. So we built, originally our mobile website where people just go purchase stuff. Back then, we've redone it twice in the last 5 years. I'm going to talk a little bit about what we've learned so far along the way. So our first take was, this was 2012, 2013, when Angular was starting to garner momentum and so on. We started with a single page application, and the first thing that we noticed that started pissing bots off. Okay, even more than that, like browsers, not all browsers were extremely happy. So if you heard me earlier, I was talking about mobile websites. So in this case, we don't have IE. It's all mobile devices. Most of them will be low-end Android devices. And the problem with these devices is that little thing over there. It's the Android native browser or the Samsung native browser as well, which are kind of, I would say, not optimal at managing and running JavaScript, okay? So we said, okay, there is this huge problem of like people not being able to, access our services very well on very low-end mobile devices, because we're feeding them, a single page app. Now the browser has to do all the work and so on. Let's try to do things in some other way. And back then we were playing around with this concept of isomorphic JS, or the way it was called back then, things that can run both on the client and the server, which is now known as universal JS. And I like to think of universal JS as something really great on paper, but then it only works in movies. So we gave a talk at this very same conference around 2 years ago about how we decided to build it and so on. And the problem is that the clients will still be angry, because at the end of the day, you will render from the server, and then you'll feed them, like a huge single page application that starts to take over after the first page load. And worse than ever, we decided to build, like a small isomorphic framework for server and client-side rendering on our own. Back then, it was like 2013, 2014. React wasn't as established. The front end, the tooling system around universal JavaScript wasn't that great. So we decided, okay, let's try to build something small. And this is how it kind of looked like. So we're approaching launch. Everything is good. We're cruising. And then, of course, after a while, boom. So, building this kind of stuff in-house is definitely not the greatest idea. The problem is that back then we didn't have enough tooling available. And so we said, I think last December, we sat down with a couple members of our team, of our front-end team, and we decided, okay, why don't we have a look at this again? And we rebuild it in, like some sort of fundamentally better, simpler, easier way. We looked at the performance of our sales and so on, and mobile, and we're like, look, it's definitely not doing great. We can unlock more potential. So what can we do right now? We had mainly four objectives. One was to simplify the code base, like move over to established tools and so on. Have better client-side rendering performance, and that for for me, it really meant, like try to offload as much as possible from the client, which seems counterintuitive. Of course, a better return on investment, because that's what we're going to measure at the end of the day, and more appealing looks, in the sense that we had a very old traditional, not traditional, like a very old UI, and we wanted to clearly give it a fresh look. And we thought, like, what is the best website ever that you could ever access on, a mobile device? Like, if you think of like the best experience on a mobile device, well, it's an app, At the end of the day, because the level of performance that they gain, it's basically unmatchable. You got smooth transition, the perceived performance is really great. So at the end of the day, that kind of gives you the feeling that, oh wow, I'm browsing something like really neat. And can we match that with, like just the web? So I think single page applications are bound to very closely bridge the gap. At the same time, I think it's added complexity. That's just my view. So I would say generally no, in the sense that you won't be able to obtain the same exact feeling of native, okay, with just a single page app. There is a bunch more complexity that you have to handle on the browser and so on. The thing that we asked ourselves is, do we actually need it? We started looking around competitors, worldwide competitors, and other services, and when I look at Amazon, that doesn't look like the most appealing website to me. It looks like a page split into two colors. There is some ad here and there. It's definitely not the sexiest page on the internet, but it works. Okay? And it's server-side rendered. You look at Wikipedia, content is king there. It's basically black text on a white background, some images. Yet we use it every day to get more knowledge, right? And funny enough, when I went on Reddit, I was like, okay, these guys are telling me just drop it, do not use the mobile website. Please, please, please download the app because it's so much better, So we looked around and we're like, look, do we actually need to match, like a mobile application? In the case, no. Probably if we do, if we do like a good effort on having like great server-side rendering performance, and we add a touch of interactions and so on, that will probably give us 80% of what we need. At the end of the day, service is king. We go on Amazon because they have the best products and like a seamless delivery. We go on Wikipedia because that's kind of the single source of truth and so on. And what we use is what I call the B stack, which is nothing fancy. It's just the B stands for like the boring stack. Okay. We use Node. We use Express, so like very, very standard tools. And on the front end, we've like attached React on our views, and we're like, okay, we can enhance the experience with React, and we bundle everything together with Webpack. So it's a pretty standard. It's pretty boring. There's nothing crazy about it. And now I want to talk about a little bit of the optimizations that we did. And on the server, I'm telling you, there's literally nothing. It's a flat earth. We didn't do anything extremely crazy. It's just like plain old Express routes, render an HTML file, that's it. I think on the client is where things get a little bit, I think, more interesting. So while we were building this project, Webpack released like one of the latest RCs with tree shaking and so on. And by just switching to that, okay, we shaved off, I think, 15 to 20% of our code base. So at that point, you have tree shaking in place. Webpack will just require the modules that are actually needed to run your code. It will not bundle everything all together. And we shaved off like a good chunk of our JS size. We finally got to the point where we could say no to jQuery. We need something. We would just go to youmightnotneedjquery.com and take that vanilla implementation and reuse it. Okay. So we don't want to bloat our code base with like a huge tool that does like a bunch of things that we need, but then it brings in like a plethora of stuff that we actually don't. And of course, we've been very, very much beware of performance and optimizations and the likes, because I'm telling you, these things need to run on like, first of all, like real slow connections. Second of all, on real shitty devices sometimes, actually most of the times. So we need to look at performance and say, look, how do we avoid, like doing X time the computation that we could do otherwise? Because Lodash and all this library bring a lot of abstraction, bring a lot of elegance, but they also bring a cost with that. So for example, let's say we have an object, right? It's just like a guy, and we need to, like pick a few properties from that object, okay? We want to create a new object with just like a subset of those properties. So we can use plain old JavaScript and we build the object manually, right? And imagine we have, instead of 2 properties, we have 10. It kind of gets redundant, it kind of gets tedious. Or you can also use low-pick, which is somewhat a little bit more elegant somehow, and lets you do things in a nicer way. Now the problem with that is that that approach is like 100 times slower, okay, than doing things vanilla. And so here, these are benchmarks generated with Matcha. This is 700,000 operations a second. The other one is 75 million operations a second. So we look at this thing and we're like, okay, at that point we don't need like stuff like pick and so on. Another example, if we want to pick a nested property from an object, you have underscore get, so I don't have to walk along the object tree, the object path, and make sure that everything works, doesn't work. This gives us, 1.3 million operations a second. It's pretty good, but if we take the same exact code, now this doesn't provide the same safety, of underscore get, but it gets, I would say, pretty close. That's 70 million operations a second. We're talking about 70 times faster. And now if you're doing that, looping through object, maybe through a list of products, through a list of books, through a list of users whatsoever, that's going to have an impact eventually on the CPU of the device, the rendering performance, and so on. Of course, results may vary. I've used Matcha, which is this really interesting tool for benchmarking code. I would really recommend people to have a look at it. And this is actually like a real world example from like one of our applications. So we fetch products from a source. It's not a DB, it's something different. And we want to, like serve like different content for different clients and so on. So we have a list of attributes that, are going to be fed to that specific client. So imagine that on a desktop website, you will see more attributes. On a mobile apps website, you'll see, like a subset of them. So we have a list of attributes, and then what we do after we fetch the products, we sanitize them, and we pick just the attributes that we want to show for that specific view, right? Now, we put this code right at the top so that we're like, okay, the next guy who comes in, it's going to be very easy for him to add or remove like a new attribute. He'll just have a list at the top of the module, like very, very, very neat. Now, the problem with that is that if we just use vanilla and looping through 100 objects doing that, we just save 5 milliseconds overall. And this is like real world code from one of our apps. This is actually server side, but gives you like a good idea. Now, you might think, like 5 milliseconds is nothing, like it's very noticeable. But for us, in that case, it was 10% of the request time. We have an application that takes 40-45 milliseconds to feed back an API result. 5 milliseconds is a huge deal. Other things that, like we want to somehow, of course, optimize is how we bundle code together. So a lot of times we're like just careless and we're like, okay, let me just require Lodash, okay, when I just need a few, really just a few functions, right? And the problem is there, WEBPACK or whatsoever will just like bundle the whole code base in Lodash and, like spit it out in your bundle. Whereas we can just, like require single functions and we get like 10%, maybe 15% on the code. So I would say, like this gets coupled with WEBPACK 2 and 3 shaking, but I think it's a very important thing to consider. Whenever you can split your bundles or just require smaller functions, just do that, because then it's less, kilobytes that you have to feed to your clients. Now, this is another example in terms of performance. Do you see anything wrong with this code? Like anyone that can tell me, look, I can definitely write this better. No? No one? Sorry? Yeah, whatever. Let's say I'm doing 2 loops here, So what I have, I'll just make it short. We're getting a list of articles, then we say, okay, let me just filter out. Generally, you would do these things in a DB, yeah, with a query right away, but let's just pretend, okay? So we're getting a list of articles, we're filtering out the ones that are not active, and then to display them, we just like change the title, we make it all uppercase, all lowercase. Basically, there are 2 operations that are being done here in a collection. First, it gets filtered, and then it gets modified, it mutates, right? Now, This looks very elegant, you know, like we just have the list of articles, we filter them out, then we map them, we change whatever we want. Sorry. We map them, we change whatever we want. And this is around 700,000 operations a second, whereas we can do the same exact thing with the reduce. It's one loop, it's one operation, it will iterate over the elements, and we'll create an accumulator, okay? That will just have the modified elements filtered out of, you know, based on whatever attribute you want. And it's like simple patterns, but instead of like 700 operations a second, we go up to 4 million. It's like 4 times faster. And these are like very simple optimizations that can change your rendering process. You know, you can just like cut it down to half by just using, like, I would say, more convoluted code. Of course, everyone is very familiar with, you know, like filter map, and not everyone is always familiar of doing this kind of things with the reduce, but that's like very effective. So in scenarios, in cases where you actually need that kind of performance, you know, like I would take this any day. Sprites. So we generally, you know, like the world has been using image sprites for the past 10 years. Since the advent of HTTP2, we started saying, okay, no sprites anymore. They're quite useless. Now, they're not exactly useless, but you know, I think the advantage of using image sprites is now like very much reduced. I mean, first of all, I think it's no fun at all maintaining sprites. I mean, to combine and change your CSS, you know, the positions and so on each and every time. Honestly, it's a pain in the ass. So let me just like go over a quick overview about, you know, why and how we got to image sprites and why we can just like tell them goodbye. So we got 3 images, right? Altogether they make a mag, okay? And so in the very old web, what we would do is just simply send 2 requests. Okay, we download 800 KBs. Whatever images are needed on this page, they'll get downloaded separately, okay? So we download the right amount of kilobytes, but we're establishing 2 connections. And you know, like TCP connections are not the cheapest thing in life, especially, you know, if you're adding SSL on top of that and so on. So, you know, like someone came up with the idea, okay, let's bundle all of these images together, okay? So we're just making one request and downloading everything at once. Now, the problem with that is that we're also downloading content that is not needed on the current page, you know? Because like that last image over there, now, instead of downloading 800 KB, sorry, we're downloading 1 meg. And generally, the way this looks in real life is more like we need 100 KBs in this page, and we're downloading half a meg, you know? Now, with HTTP2, I think things change for the best, all right? Because all requests and responses are channeled through less connections. You ideally need just 1 connection, and you can challenge as many requests as you want. So then what happens, you download just those assets, okay, 800 KBs. You don't need all of it, and you're just gonna establish 1 connection. That's it, sprites no more. Now, of course, there are 2 things to consider. If we're making 10 different parallel requests, you know, the overhead could still be, you know, a little bit higher than you would have with 1 single request and downloading all the sprites. And again, another thing to keep in mind is when you give your CDN or your build process 10 images to optimize together, the JZip, the flat, whatever algorithm broadly you're using to compress them will be more effective when you have like 10 images all together, okay? But you know, like we eventually found out that these advantages are quite trivial, not trivial, I would say, not very huge. So we decided, okay, let's just drop sprites, let's do single requests, because we just like use HTTP to lower the footprint of those connections. As I said, you know, like we used React quite extensively in the front end in the sense that we wanted to pick a library that wasn't a framework, and we just wanted to use it for basically client-side interactions and so on. There's no routing involved on the client, so there is nothing of that. We really just need view and presentation. And what we needed though is React without the real sauce. So you know, like React is kind of like, I would say, like heavier than other frameworks here and there. Of course, it does a great deal to you know, like avoid bloat, but at the end of the day, you have libraries with very similar APIs for like 1/10 of the size, or you know, half the size. So we eventually went ahead with Preact. It's a really tiny 3KB alternative. I would say 99.8% of the APIs that are supported by React are there in Preact. But if you're scared of migrating your old Preact app to some other comparable API, comparable framework, you could use React Lite, which kind of ensures 100% API compatibility, and it's just like 25 KBs. Okay, we started from scratch with Preact, so it was easy. We weren't migrating any code base. But if that might be your issue, then at that point you can just use React Lite. Sorry. CSS animation. Now these GIFs, of course, are like suck because like the way I recorded them, they're like super slow and so on. But you know, we've put a great deal of avoiding JavaScript animations and simply adding like CSS transitions as much as possible. So when you click on an add to product, things will pop out. Very nice. Users will like it. Okay. And one very tricky feature that we decided to implement. Now let's see if I'll be able to play this. You guys see the pointer? So we are building a server-side render application, right? But there is one trick. So let's see. We're clicking on a product here. We show a preview. This is not server. And now, boom, the new page has come through. Got it? So browsers will do a great deal to avoid showing the user that the page is actually being reloaded. If the same elements are in place, there is no flickering, there is no nothing, it's a seamless transition. Okay? This is like a very quick hack. So once you click on a product, you'll show like a bare minimum preview. And then when the page loads, the browser will make sure that the transition between the previous view and the new view is as seamless as possible. We've also done, like a bunch of optimization with not just in the JavaScript code, also like in the way we do networking, and by dumping, like a bunch of interesting stuff into our HTML and CSS and so forth. So for example, pre-connecting, what we do is as soon as the browser, like is a streaming parser, so it will get a bunch of bytes, parse them, and go ahead and hide. So what we do is, as soon as the browser gets a little bit of content, we tell it, look, start creating a connection, okay, to our CDN. So that because you will need other assets later on, okay, and it's important that you already have that connection established so that you can just request them. You don't need TCP round trips to just establish that connection. Another, I think, really interesting features. I think you're very familiar with the pain points of fonts, of custom fonts on the web. They're like these massive, huge, whatever files that you have to download before showing anything to the user, and they're generally massive, so they cause a delay. Right now, with linked preloading, we can actually load fonts or CSSs or whatsoever asynchronously. So then what happens, we specify a link, it's a preload link, okay? We tell the browser, look, as soon as you start parsing this page, you get to this link, start fetching it, okay? Don't do anything as such. It's gonna be a style. We'll give you a hint. So just use the right media types and so on. But basically just download it, okay? Don't do anything. And now the browser, and then when this loads, when the document loads, okay, change this link to a style sheet so that it will be applied on the page. And this is like a good way of doing async rendering of downloading of CSSs, because CSSs are blocking resources, right? So you wait for a CSS, and as long as it's not being downloaded, the browser will not go ahead. So what you do, you render the page, you'll tell it, look, pick my fonts from elsewhere, okay? And once you have them, apply them on the page. So at the beginning, your page will be rendered with the regular, whatsoever fallback fonts that you have, but the user has content, it doesn't have to wait for like 200, 300, 400 kilobytes of fonts being downloaded, right? And this is an example. The CSS here gets downloaded. This is one example I found on GitHub. And boom, at some point, there is a slow CSS that will apply a green background that just loads in background, okay? The page is already rendered, everything is there. At some point, when the CSS loads, boom, you'll get the style. And pre-rendering as well. So, I mean, if you have, if you visit any e-commerce website, you know that you'll look for products. At some point, there will be maybe infinite scrolling, maybe a pagination. So the user is kind of bound to, pre-render a bunch or rendering a bunch of additional assets ads. So you click on page 2 and you want to show them the second page of products. What we do in that case is we add an event listener on the document load, and what we do at that point, we create a link, okay, on the head of the page. We say, look, this link is a pre-render link. What the browser will do, it will say, look, I don't give a shit about this link as long as the user is downloading stuff. You know, like once network is kind of free whatsoever, I'm gonna give priority to this guy. So marking them as pre-render resources kind of doesn't do anything with the regular flow of the web page rendering. It just tells the browser, look, here's a hint. Later on, the user will probably need this page, so you can load it in background, okay? And then we append it basically to the head. And then what that does is that when the user clicks on the new page, okay, the new page is already cached. Resources right there are already cached. You see the first 3 images because those are the ones that get rendered right at the beginning. The other ones are kind of lazy loaded, and that's why they get loaded afterwards. So the browser in background is actually doing a full render of another page, okay, for you. At that point, you don't need to load JavaScript. Everything comes from the cache. I mean, you tricked it to load all the assets beforehand. But I think, you know, from a user perspective, it's definitely, you know, like a nicer experience because it's just gonna click and it's like, oh yeah, I see everything. Now he's gonna shout at you because, oh shit, my data's gone. You know. Splitting assets as well. I think, you know, we've traditionally worked in a very simple way where we have one JavaScript bundle. That's it. You know, we ship it on each and every page. The problem is that at some point, you know, like that bundle could be 2, 3, 4, 5, 6, 700 kilobytes whatsoever. It's a huge chunk of JavaScript, right? So the way we've decided to split things is by page. Okay, so this is the Webpack configuration. So all these pages represent different views on Namshi. You can, you know, of course, see like cart, list, detail, and you're familiar with that. And then what we do in Webpack, we have a bunch of common modules, okay, both on our userland code as well as vendor modules that we keep on a separate level. So then what happens, what the user actually downloads is, okay, the Webpack runtime is like a tiny JavaScript, then the vendor.js, which rarely changes, okay, and the app.js, okay, which is the common code in our userland. And then there is a block that we extend from the server where you're just going to embed the specific JavaScript for that page. Now that's more HTTP requests, right? Because we have 4 of them, but who cares? We're using HTTP too. That's all good. And what that does is that it gives us, you know, on the first page load, it's going to be faster because the user has to download less JavaScript. It doesn't have to download a bundle for your entire application. Okay, it just has to download a bundle for that specific page. And when it transitions to a new page, it just need to get these will be cached, and it will need to just get like the small chunk for that specific page. You know, like maybe 50, maybe 60, maybe 70 kilobytes. That's it. We consume less bandwidth because ideally you don't have to serve everything at once right at the beginning, and it still gives you like a good hit rate in terms of caching, you know? Because, for example, vendor files, they will rarely change. Probably the share code between in userland will not change as frequently. So at that point, we still, you know, like it's a trade-off, but I think we still achieve like a very good hit rate. And what we did, we wanted to compare it a little bit with the rest of the industry and so on, just to see, you know, what goes around. So, for example, right now, if you exclude tracking scripts, analytics, all the bullshit the marketing wants to put on the website, you know, we do around like 7 requests. It's 100 kilobytes. When we started working on this, we sat down, we spoke with our engineers, and we're like, look, it's impossible that in 2017 we can't make an application that doesn't require, you know, like less than 100 kilobytes of JavaScript. You know, we should be able to, 100 kilobytes is a lot, you know, especially a mobile connection where you're on the metro or in a farm in Oman, and you know, like you won't have like the greatest bandwidth, you know. At that point, we're like, look, let's just try to make something that has the smallest footprint possible in terms of bandwidth. So we looked then at Amazon. It's very similar numbers. Yeah, 9 requests, 150 kilobytes. That's actually very impressive because I assume their tooling, their infrastructure is way, way bigger. And if you compare it, for example, with Twitter's new progressive web app that rolled out a few weeks ago, like they do like something very similar, like very less requests, but they feed you a bigger bundle because then the progressive will the front end app, the single page app, will take the stage right after it's being rendered, right after they serve the HTML. So they put still a lot of logic on the client. To me, it's somehow, I feel, like if you want to optimize for like very slow connections, you have to minimize that impact of loading all of that JavaScript and so on. Results, to be fair, I'm going to share with you like a bunch of numbers. The average document time was cut down in half. Okay, and this was just thanks to server-side rendering, shrinking as many dependencies on the front end as possible, and that's it. The bounce rate, which kind of indicates, like bounce rate is when a user comes onto a page and then he leaves it immediately, which means that you screwed up something, or the user doesn't like it, or there is an error, he doesn't see the product whatsoever. The bounce rate is down 15%, meaning the user are less scared of the website. And one very important thing, the average session duration, which is how enjoyable it is to experience, like this product, is up 40%, which is, like a huge increase. It's basically for us, like they jumped up, around 2 minutes, 2.5 minutes right away. We switched the button, we deployed, and we started seeing these things right away. And conversion rate, of course, we're talking about revenue, return on investment, and so on, is up 30% with spikes in some of the countries that we serve, spikes of 70%. Now that's my opinion. That's because we've unlocked, we also double check numbers and they check out. That's because with service-side rendering, we unlocked, like a whole set of devices, okay, that would have a great pain dealing with, like predominantly JavaScript apps. Because they're like very low-end devices, they won't run very well there. So we just feed them everything from the server, and that's kind of easier for them. So I think like that's why in some of our countries we really unlock like a great deal of potential there. It's because like we tended to keep things as simple as possible. Sorry. What we're now looking at, it's just like a very, like brief list of the tools and technologies that we would like to implement because we think, like they're gonna be able to let us simplify even further in the future. So first of all is gRPC. How many of you know gRPC? That's perfect. Because it's not yet available on the web. gRPC, it's a framework. Let's call it an API framework from Google. It lets you write service definitions and service objects, and Google uses it all over their internal and some of the public-facing infrastructures as well. So what it does, they let you specify your service definitions, and they generate servers and clients from you. So you say, hey, I'll have this API, which is kind of this address. They don't have addresses in gRPC, but it will say, look, when you send a request to this API, I'm going to return you an object with name, yada, 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 okay? And you just write that definition. You'll implement the logic of the code, and you'll hook it up on the gRPC server. The gRPC server will also be able to generate the client-side code, so we don't have to use XHR anymore whatsoever, because you have an SDK generated directly by that. Now, that's kind of scary, right? Because it's like automated code generation, these RPC frameworks didn't work well in the past and so on. Personally, to me, if something comes out of Google and it's being used like in production-ready systems for a while, for example, CoreOS uses it for etcd and a bunch of their products, I'm generally very excited because now one of the biggest pain points, like when you have to consume an API is, fuck it, what's wrong? Like, is the camel case, the lowercase, what's the address, what's the version? And you really don't care about this stuff. You just want to hit that API and get a response back. And gRPC, avoids all that overhead. You'll just ask, like the guys who implemented the server, what's the address? Just give me like a host name, give me a port, and I'll start consuming it with the SDK that you provide me. So that I think will simplify even further management of like API-based applications. Push notifications, I think it will provide like a great deal in terms of customer engagement. I think we've been playing around with it. It's currently under development. I would really recommend you guys, if you do a lot of web mobile development, to have a look at Firebase because they give you a set of like like a good library to do this without too much pain. You will be able to enroll the user to to pushes, to save those tokens, the enrollment tokens to the Firebase DB and so on. It's pretty seamless. It's, I think, like a very interesting approach, because if you want to do everything from scratch, it's kind of painful because you need to build the push infrastructure for that. Content security policy, which I think it's one of the biggest, biggest revolutions against cross-site scripting attacks and all of that sort. If you followed GitHub had like 2 great articles explaining their journey across content security policy. And content security policy, what basically does, says, look, I want to whitelist these vendors on my website. So if someone tries to inject a script from somewhere else, the browser will not allow it at all. Okay. What's interesting is that you can try and play around with it today. There is a header that you specify, it's content security policy, yada, yada, yada. And one of the nice options that you can specify in that header is report only, okay? So what the browser will do, it will just send you a dump at a URL that you specify of all the violations of the content security policy, okay? So you can have a look at it and say, okay, to generate my content security policy manifest, I need to whitelist, okay, google.com because they serve AdWords, whatsoever, or Criteo.com because that's my marketing provider. One of the great things of content security policy is that it can disable inline scripts. So if you have, if you have like an XSS attack where the user can just dump JavaScript like in a URL and that gets executed right away on the client's browser, you can avoid that right away with content security policy, because you can say, look, inline scripts are not allowed at all. Okay, it's just going to be, like my JavaScript that comes from the CDN that is able, and I'm just going to allow the CDN, that CDN's JavaScript to be loaded in page, and no one else can run JavaScript on that page. It's a great security measure. You should really have a look at how GitHub implemented it. They did a post, I think, around 2 years ago, 6 months ago or something of that sort. They did a follow-up saying, like how they found themselves implementing stuff and what still was kind of broken for them. It's a great, it's 2 great posts. Another thing that I think it's really far away, but it's definitely interesting. Now you'll have to bear with me a bit, and let's see if we got a Wi-Fi. So. Now, we were talking about page transitions between server-side stuff, and we said, we can eventually, like kind of have the same layout, and the server will be, and the browser will be able to mask the fact that they come from the server. This is a presentation, I think, from like some random Google event. Please, Wi-Fi. From some random Google event a couple of years ago. Let me just see if I can get there. Not really. Just give me 30 seconds. Here we are. Come on. I think the Wi-Fi is not very collaborative. Anyhow, basically, look, there is a proposal for a web page transition. So you look at this is server-side rendering, okay? Now, I don't know if I'm at the right point in the presentation. It's still going to be loading. What Google wanted to propose, this was 2014, was a way for you to transition between pages. And this is server-side rendering, okay? That's server-side rendering. And the browser takes care of moving things around, okay? And then at that point makes it look like a real app. And you don't need the overhead of a single page application where you can control the transitions because the page doesn't really reload and so on, right? So I think that's somehow unfortunately like an old abandoned idea. I think we're still quite far away. But Jake Archibald, he's one of the web engineers working at Chrome, has came out with a new proposal. It will take months, maybe another couple of years to get there. But I'm sure like there is a certain interest in that, because that will make like server side hot again. My last, and I have like literally 2 minutes, advice is that I think hot is generally overrated. Don't pick something just because it sounds great. I was talking to these Google engineers when we implemented AMP on our website, and they were telling us, why don't you use service workers for caching, yeah? And at the end of the day, if you just implement HTTP caching and you have static assets, you will not need service worker caches, you know, because the HTTP cache makes sure that your stuff can still be working offline, you know. If you set the right headers, the browser won't need to make a real HTTP request to your origin server to get the JavaScript again. So in that case, it's not just because the service worker looks amazing, you should use the service worker cache. It doesn't make no sense. You can quote me on that. There are like certain places where you want to use service worker caching. For example, if you have a huge list of assets, so for example, product images, and you're like, look, I'm gonna be wanting to load 20, 30 more for the next pages later on, and I'm gonna be loading them asynchronously with the service worker, and I'm gonna fill up the cache gradually. But other than that, if you have to serve JavaScript, CSSs, you know, like you don't need service worker cache. You're just better off with HTTP caching that's been there since 21 years, I think. Solve problems on the right layer, and this is a quote not from me. It's from actually the engineers working on AMP from Google, and they'll tell you, you know, like don't just push things to the client if that's not what's going to solve the problem. You know, if server-side rendering would still be beneficial for you, go for it. Servers, at the end of the day, can still be pretty fast. So just to give you a perspective, this is one of our clients, this is our mobile website, and that's an API. It fetches data from an API, you know, like very simple. It doesn't talk to a DB, it fetches data from another service. So this is kind of the performance of the service. You might be tempted to look at the average response time, but averages make for a real shitty KPI, because you could have 50 requests at 1 millisecond and 50 requests at 3 seconds. Now the average could still look decent to you, right? But the truth is that 50% of our requests are like super slow. So what you really have to look at is median and 95th percentile. That will tell you, you know, how are you serving like half of your traffic. In this case, half of our traffic is served within 30 milliseconds. And this depends on another service. Now, 95% of our traffic gets served right away within 120, 130 milliseconds. This is the 99th percentile, which is the really extensive one, which is around 180, 170 milliseconds. And I would take this any single day. 35% of the requests get served within 10 milliseconds from a server. Don't need a client to do things that fast. Not all the time, right? This is an incredible, a very nice histogram. We use New Relic to monitor that kind of performance. I would highly recommend it. But this shows us the percentage of responses that are served within a time frame. And of course, measure costs wisely. You'll be like, tomorrow you'll be like, oh yeah, let's put everything back to the server. We've been dumb until now. No, look. You have to measure, you know, because at the end of the day, for example, servers will generally cost you more because you're not just serving static assets, you know. You're not just serving like a CSS, JavaScript, and HTML. You have to do the computation on the server. So that might increase your AWS bill. You know, things like this. You have to keep a lot of things into consideration. It's not just like, oh, let's all go single page application. Oh, let's all go to universal JavaScript. Oh, let's all go back to the server. It really depends on your use case. And I think that would be it for me. I'm Alex. You can rent this unfriendly Twitter handle. I work in Namshi, as I said. We're an e-commerce retailer, the largest fashion e-commerce retailer in the Middle East, where I work as a CTO here. I rent and write a lot of useless shit, trust me, on Odino.org. Thank you very much. There's one more thing. Chirpo forced me to put my joining talk thing. So if you guys want, actually, I would recommend you to go there, give me like very transparent feedback. You can say, you suck, you suck, you suck, because I hear that every day, so that's fine. Yeah, we're also hiring. So if anyone's interested, we are based in Dubai. We're currently looking for mainly backend engineers to help in our backend team. If you guys are looking for a gig or would like to change places around, just have a chat with me. I'll be here for these 2 days. We'll be very happy to talk. Thank you.